Hello everybody. I'm here to talk to you about open source BIOS at scale. So who we are? We are basically online Scaleway. It's a hosting company from the French telecom group Iliad. Iliad is better known for free telecom. What we do is we build our own data centers in France. And in our data centers, we build our own, some of course. Yeah. Yeah, I'll try. So we are a hosting company. Online Dedibox is to the brand we have for server hosting, and Scaleway is the brand of our cloud service. And to provide those services, we have data centers that we manage ourselves, we build ourselves. And in those data centers, we put servers from Dell and we put servers that we built. And in those servers, there is an ARM32 offer that's called C1 on our cloud service. It's basically, I think we were the first to do cloud on ARM32. And then we went to a more x86 kind of server with Intel Avoton. And the new ones, the one I will talk the rest of the talk, is the Denverton chip. And Scaleway is hiring, so if you're interested in those kind of job, come with us. So what we did is we developed an open source BIOS. What was our requirement? Basically, bring up the board, do PXE booting, so boot from the network, have the OS ready, so we need the ACPI tables and stuff like that so that the OS knows how much CPU you have and how to change the speed, etc. We need some interface with our BMC so we can do a remote console and configure the system from the administration network. We need an update, secure update process. We need to be able as a hosting company to update the BIOS and not our clients to flash their BIOS if they wish. It's our job, not theirs. And I think I did everything. And why go open source for that task? We tried BIOS vendors. Basically, they sell you something that almost works, but does not really do what you want. They give you some sources, they give you some binaries. Whenever you have a question, you have to ask support, and they're not quick to answer you, and you pay extra for that. So it's not really a good solution. And basically what they are selling to you is the initialization of the chips that's from Intel. They're giving you an UEFI stack that's basically from China Core. And their legacy BIOS and a very nice menu with the mouse clicking to configure your system, which we don't need. Another solution was to use Intel's reference BIOS, but you're not allowed to do that. They give it to you just for testing, but you can't go in production with that. And none of those solutions did cover the interface with our BMC. So we need to develop something. So we went for open source to do that. So mainly there's 3 components: Core Boot, which is open source, community-driven effort; FSP, which is the black box from Intel; and Core, which is the UEFI stack. So Core Boot does the early init. The first stuff that's run is from Core Boot. Then it passes to the FSP to do the memory training. Gets back to Core Boot, we do the multiprocessor init, we prepare the CPI table and stuff like that. And we need to call the silicon init from Intel. It's doing more few stuff like locking some registers so it cannot be changed afterwards. And then we run Tano core. Basically, it could be unchanged using the core boot payload from Tano core project. We did a few changes in there also for the BMC support. So basically, we took all that, and it worked. No. It almost worked. First, I was still learning the core boot cost base, etc. And your system boots, you're happy, and you're on Linux, and you have high-end CPU, and it's running at 800 megahertz. Whoa. So you start searching on ACPI how to configure those speed step features so that the Linux knows how to change the frequency, etc. Still doesn't work. And then you go somewhere, you read the Intel documentation, and you have to configure some stuff. So you look into the core boot, how it's done for the chip, etc. You mostly find stuff that look like, but it's not the same chip, so it won't work. And at some point, what was in my documentation and what was on core boot upstream Apollo Lake support was this will do the initialization, but it's not really documented. Okay, should I use that? I asked Intel support. They said, yeah, it's that code. So I integrated it, and that was it. It was booting and running at 2 gigahertz. There's some other stuff. That one is fun with the NVMe drive. That one from Samsung is working fine, and the one from Intel was not working. So we had several exchanges with the Intel support, and they finally found out why. So it was some configuration failure, but we couldn't find it easily because we don't have debug tool for PCI Express. So what's good? Pros and cons. I start with the cons. It's a little longer to develop than using BIOS vendors. We don't have the nice graphical menu.
That's not true anymore since yesterday. We uploaded some.
Yeah. We don't have legacy BIOS support. We could have used CBIOS for that if we really wanted, but we didn't. Intel's bug were for us, not for the vendors. So we had to talk with them. We don't have BIOS vendors support, but we had Intel support. So. And that one is important for the community. Early contribution is hard. Basically, the first version of core boot that we had was before the chip was even released. So it was under NDA, and we didn't have right to talk about it. Denverton, nobody knew about it before it was out. So we couldn't contribute at that time. And when Intel contributed something to core boot, it was a totally different code base. So basically, what I have to do now is rebase everything and redevelop some of the features to contribute. And I'm in the process of doing it. The good thing is most of the code is already there, and even more now on core boot. Basically, it works, it fits units, and it's as fine as the Intel reference BIOS. Performance as here, discard detected, everything. We have some more features related to our BMC. We can configure the UART for the console to display information about BIOS or not, stuff like that, which are really useful for debugging, but we disable them in production, so it's easier to have configuration there. And about the flash, basically the system, our BMC locks the flash, and the Intel FSP is configuring the flash controller to protect also the access to the flash from the host. Basically, in a regular system, only the ME component has access to the flash once it's booted. And when we want to update, we want to use flash ROM from Linux. So we have a special mode where we go around the protection set up by FSP so that we can write to the flash. Yeah, and one good point too is when discussing with Intel on the memory reference code, this code has a lot of information about the training of the DDR, and we wanted to get those information for our inventory. So we wanted those information to be displayed on boot. And basically, Intel planned to release the version that's released on GitHub of the FSP without those features. And I told them, yeah, but we need it. So at first they said, okay, we'll give you a special version under the NDA. And finally they said, oh, we did put the version with the MRC code on GitHub. So thanks to us, everybody has access to that. So it wasn't the investment. Scale we had to hire me. But it was useful, and we're really happy to have the control on our burst stack. So that was just a few prototypes, and it's going fine. Yeah, by the way, we are producing lots of those. The next scale we run on those. Any questions? Yes?
You were talking about training the DDR. What do you mean by training?
Yeah. Basically, when DDR3... Yeah, okay. The question was what training the DDR means. Basically, on DDR3 and 4, the link between the CPU and the DDR, it's like a small network on board that's run really, really fast. And it's not like you put a one, you get a one at the other end. It needs to fine-tune the way it controls that. And the specific code to do that, we don't have it. It's Intel proprietary. We don't even have the datasheet of that part. Yes?
What about the management engine?
In our case, yeah. What about the management engine? In our case, we are a direct Intel customer, and we are using it. I mean, the management engine has the role to bring up part of the platform. Yes, we know about AWT and all those. We don't have those features in the version we have. We know it. But
it was released to you by Intel under NDA?
yeah, it's part of the stuff we have under NDA are the same as the other manufacturer. We're like, yes?
Can you talk about the implementation of what's running on the BMC? How will you implement it?
Okay. What's running on the BMC? Basically, our BMC is a small microchip, and how we implemented APMI. Basically, we have a UART forward to TCP port, no UDP port. So it's not a full standard APMI. It's really just the feature we need, and then we have applications that run on other computers in our network to handle the tasks. It's not a standard APMI. Yes?
How long did it take you for this project, and with how many people?
First, the second question, one people, me. And how long? I started, I think it's about 6 months, a little more than 6 months work. It's been more than a year, but during that time there was BIOS development, BMC and stuff, and when you're waiting for the support and you have no clue about the specific bug, you switch to something else. So it's more than a year, but it's probably 6 months learning core boot, learning EFI, and that one is a pain, and tweaking those stuff, etc. So, yes?
Planning to try Linux boot instead of Piano Core?
Are we planning to try Linux boot? Yes. As I said earlier, for contributing, I'm still in the process of upstreaming our changes, and I see it as a requirement before trying Linux boot because it's integrated in latest core boot. And then we'll see. As a developer, I will try it, and we'll see how to deploy it, if it has benefits or not, etc. I think it does. If there's no more question, then I'd say I thank you very much for being there, and probably see you next year.